We are going to start S1, Statistics S1, which is paper 5 of AS level. As we know that if we are going to appear for AS level, we have two options, either to choose P1 or M1 or to choose P1 or S1. These are the two possibilities. So now I'm going to tell you about the marks distribution for that. It is of 50 marks paper. 1 hour 15 minutes will be time given and 7 questions will be given in this paper for 7 questions. This paper is very high percentile paper. You can get your A on 43 from 50. If the paper is very easy, then it can reach up to 46. Okay, but that's a rare chance when the paper is going to be easy on. Okay. As I told you before, this is a high percentile paper. This means that if you are going to incorrect 1 or 2 questions, it means that you need to forget your A. Okay, so if you want to achieve good grades in this paper, then we tell a strategy for this to the students to solve the paper. Okay, if you are going to follow the strategy which I'm going to tell you, then I can give you guarantee to get the chapters which are going to include in this course outline are one. First chapter is binomial distribution and random variable. Second chapter is permutation and combination. Third chapter is probability. Fourth chapter is normal distribution, and fifth one is representation of data. The fifth chapter, which is representation of data, is has the same content as O level. So I will explain this chapter to you at the end, so that if we are lacking in time, we can wind it up within quickly. Today we are going to discuss probability. So what is a probability? Probability is basically study of a chance. It's a study of chance. So what is meant by chance? Like sometimes we say that there is a possible there is a 50% chance of a rain. Okay. So 50% chance. This 50% chance is basically a probability. Okay. How can we convert chance into a probability? To convert chance into a probability, we need to remove the convert this percentage into fraction. Like 50% will be converted into fraction and it will be 50 over 100. So 50 over 100, let's simplify that. It's going to be cancel out with this one. 5 ones are, 5 twos are, 1 by 2. That is the probability of rain. Okay, so 50% chance of rain. Okay, rain chance was 50%. To convert chance into probability will be 1 by 2, which will be the probability of getting rain. Okay, that was that. Now let's talk about the formula of the probability. So the formula of probability is probability of event is equal to favorable outcomes. 1 minute. Favorable outcomes over total outcomes. Let's talk about their units now. What is the unit of probability? Probability is a unitless quantity, no unit, because it's a ratio of two same quantities, because it's a ratio of two same quantities. Same quantities. All right, let's talk about the important terminologies. We are going to discuss some terminologies. These are the important terminologies. What is an experiment? So what is an experiment? An experiment is a repeatable activity. Okay, an activity which is going to repeat is known as experiment. A repeatable activity. Same way event. What is meant by event? Event is basically all possible outcomes. Okay, all possible outcomes. And sample space is all favorable outcomes. There is one more thing to express. Basically, event and sample space can be same, but the difference is that the sample space will always be written in terms of curly brackets. Okay, you have to write your sample space in terms of curly bracket, and it will be starting always with some of the capital letter, with any capital letter from A to Z. You can choose any, but it should be capital. Okay. There is one more thing which we are going to discuss is an outcome. What is an outcome? Outcome is basically it's a result of an experiment. Result of an experiment is called outcome. That will be an outcome. Okay. Now let's discuss few examples. Let's see that there is a tossing a coin. If we are going to discuss tossing a coin, it means that our experiment, what will be our experiment? Our experiment is to toss a coin like we are going to flip it. Okay. It's going to have two sides. So our sample space will be like I'm going to write it with S. So sample space will be head or tail. So whenever I will be tossing a coin, I am having a chance of either getting H like head or tail T. Okay. So my possible outcomes will be two. These will be the possible outcomes. Like two will be the possible outcomes, either head or tail. I cannot get head and tail at the same time. I'm having the chance of getting either head or tail. Okay. Like there is a 50% chance of head and 50% chance of tail. This shows that this is an equally likely event. It's an equally likely event. Equally likely event. What is meant by equally likely event? Equally likely event means that the probability of appearing any of this event is same. Okay, like head can appear at the same ratio as tail. They both have the same probability. They both have the chances of being appear at the same rate. Okay, so a fair dice rolled. If we are having a fair dice and which is being rolled, so my sample space will be like I can choose any number to start with the sample space. So my sample space will be fair dice. A dice is having six sides, so 1, 2, 3, 4, 5, and 6. That will be my sample space. Now the outcomes, which is supposed to come. My outcomes will be six only. Okay, each number can appear only one time. Okay, like if you are rolling a dice, so you have the probability to appear this event at the one time. It means that this is also an equally likely event. Each number has the equal probability to appear. So outcome is 6. Now let's talk about the tossing of a coin and a dice. In this case, I'm going to choose two different events. Okay, and what are these? First is that I'm choosing a coin and a dice. Suppose that my coin is having head and tail, and dice will be having 1, 2, 3, 4, 5, and 6 sides. Now whenever they both are gonna roll together and a dice together, our sample space will be 1H or 1T. Okay, same way, 2H, 2 tail, 3H, 3 tail, 4H, and 4 tail. Same, 5H, 5 tail, 6H, 6 tail. That will be our sample space. Now the possible outcomes. Let's talk about their possible outcomes. What are the outcomes? Which will be? Total outcomes. Let's count them all. 2, 4, 6, 8, 10, and 12. So total outcomes are 12. These are the possible outcomes which can figure out after this experiment. Okay, let's talk about two fair dices. If we are having two fair dices, so O levels allow you to make two kinds of your distribution of your sample space, either to this form, okay, or like this graphical method. Okay, so what am I going to do? I'm going to do this with the graphical method this time so that you can get to know about this. So if this is 1 1, so I will put the dot over here. Same way, 1 2, 1 3, 1 4, 1 5, and 1 6. In the same pattern, I'm going to do for 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. 3 1, 3 3, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. Same way we are going to complete this. This is also present in Cambridge course outline. Okay, so you can draw your sample space like this. So how to define that now? So it means that if I want to explain any of the point like this one, it means that my this point is its x coordinate is 3, 4, 5. 3 and 5 will be its x coordinate. Same way, if I want to pinpoint this point, then it will be 2, 3. So that is my sample space. Now the possible outcomes, total outcomes. How many total outcomes are present? Total outcomes are 6 by 6. So these are 36. These are the total outcomes. So let's draw the tree diagram. This shows that John is going to have 2 attempts. Okay. So let's assume that that will be his first attempt. And in his second attempt, he is going to have again same way fruits and desserts. Same way fruits, dessert, fruits and dessert. Now it says that in his first attempt, he has probability to get fruits. Then after fruits, he was still hungry, so his probability to having dessert is 0.6. Okay, like after fruits, he has taken fruits. So after fruits, he has the probability of having dessert is 0.6. Now the probability of having fruits after dessert is 0.7. Okay. Now it says that if he has desserts in his first attempt, and probability of having fruits is 0.7. Now, the thing is that he says that find the probability that he has desserts in his both attempts. Okay. First thing is that we are going to complete this tree diagram. Then we will figure out this last part, which it says that um, he has taken dessert in his both attempts. Okay. So what there is a rule for attempting tree diagram or making a tree diagram. So what is the rule? First rule is that for every point, if a branch is emerging from a single point, then sum of probabilities will be equal to 1. Will be equal to 1. Second point. Second point is that if we are going to calculate branch probability, we have to multiply their probability. Okay. For branch probability, multiply their probability. Same way, if we are having more than one branch, for more than one branch, then we are going to add individual branch probability. Add individual branch probability. I will explain this to you. Okay, we are going to apply rule number 1. So rule number 1 says that if a branch is emerging from a single point, then sum of their probability is equal to 1. Okay, it means that this was the emerging single point. Okay, this branch was emerging from this point. So sum of the probability is going to be equal to 1. Okay, so if this is 0.2, then this will be, if this is 0.8, then this will be 0.2. And sum of the probability will equal to 1. Same way, if this is 0.6, then this will be 0.4 and sum of the probability will equals to 1 because this is also emerging from one single point. Same way, If this is 0.7, then it's gonna be 0.3. I hope you have cleared your point one. Now let's talk about for branch probability, multiply their probabilities. Okay, it means that if I want to calculate even if I want to calculate a branch, just like it says that find the probability that he has dessert in his both attempts. Okay, if we are going to find that. So the dessert in his both attempts. So dessert in its both attempts, that will be the dessert in his both attempts. Okay. So this also satisfies the rule number two. Rule number two says that for branch probability, multiply the probability. It means that I will get my probability like DD, it will be 0.2 times 0.3. That is a multiplication. As it says, multiply them. Now simply multiply them. We are going to get 0.3 times 0.2. It is 0.06. So that is the probability like he is getting dessert in his both attempts. I hope you have cleared your concept till here. Take care. Bye.